This question, they're giving me a function. I brought it down here. It's up there as well. And they want me to find df dx. Now, I don't know if you're used to that notation, but well, here, let me get that first. Before I do that, it just means derivative. That's the same as f prime of x. It's just, this is Leibniz. It's one of there's two people that discovered calculus, Leibniz and Newton. This is one guy's notation, Leibniz. This is Newton's notation. They're both fine. They both mean the same thing. Okay, anyway, but before I do that, I'm going to rewrite to make the derivative easier, f of x. Specifically, this is going to become 2x to the minus 1. The other part is going to stay the same. Now, why am I doing that? Well, first off, do you know that's true? Do you know that x to the negative 1 power is 1 over x to the positive 1, a regular one? Just like, I don't know, x to the minus 3 is 1 over x to the positive 3, etc. You aware of negative powers? Negative powers flip to the bottom and then they become positive. Like somebody negative at their job. They're unhappy at their job. They want to jump to the other side of the fraction. They want to jump to a new job. Then they're positive. Then they're happy. So negative powers are always unhappy where they're at. They want to jump to the other side of the fraction, then they become happy, positive. So therefore, um, x to the minus 1 power, right? This is really over 1. I'm not going to show that, but that's what it is, right? It's not in the bottom. So why am I doing that? Well, because I don't want a fraction. Let me just say that. I do not, I do not like fraction. So if I can avoid a fraction, I'm going to. And here's how I can avoid it. I just write it as x to the negative 1 power. That's the same thing as x on the bottom, right? Because this is really an x to the 1, positive 1 on the bottom. So why don't I like fractions? They're a pain. You got to use the quotient rule. If you have a fraction and you do the derivative, that's called the quotient rule. I don't want to do the quotient rule. It's a pain. If I can avoid it, I'm going to avoid it. So anytime I got a fraction, when I can, you can't always. That's why we have a quotient rule. But sometimes you can avoid it, rewrite it as not a fraction. So then take the derivative. Now it's derivative time. So f prime of x. How do you take derivative? The power comes there, right? Minus 2, and you subtract 1 from the power. X to the minus 2. Is that good? And then minus 6. Now, what's the derivative of cosecant? Well, so you need to know those. Let me write them out for you real quick. The derivative of sine is cosine. Oh, whoops, sorry. That was a mistake. Um, sorry, I just went to the wrong place. Let's see if I can get back there for you. Nope, I'm just just out of luck. Okay, wait, let me see. No, that is not it either. And there it is. Sorry about that little foray. I found it. All right. Anyway, derivative of sine is cosine. Derivative of cosine is negative sine because the derivative of sines and cos derivative of every co-function is negative. Okay. And then what are the other ones? Derivative of secant is secant tangent. Derivative of tangent is secant squared. And then, keeping with our same principle, what is going to be the derivative of cosecant? Notice it's cosecant. So it's going to be the same answer as this, except it's cosecant, cotan, and it's negative because all cofunctions are derivatives negative. What's the derivative of cotan? Well, it's co this, so it's going to be cos. It's going to be this cosecant squared, but it's going to be negative because derivative of all cofunctions are negative. So there's the 6 trig functions and their derivatives. So we need to know that. So the derivative then of cosecant, where is it? Oh, right here, is negative cosecant cotangent. So negative cosecant cotangent. I'm kind of running out of room here, aren't I? So let me squeeze it in down here. So then we've got F prime of x equals, bring this on down, minus 2x minus 2. And then bring this down. What's it going to be? Well, it's negative 6 times 2 negatives multiplied to be positive 6 cosecant x cotangent x. So the derivative of cosecant, of cosecant, is cosecant cotangent. It says right there. And it's negative, because the derivative of all cofunctions, cosecant, cotangent, cosine, they're all negative. Two negatives multiplied to be positive. So there's the derivative, and they just want to, and then they want the second derivative. Okay, that's the second derivative. So there's the first derivative. That's the first answer they want. Put a box around them. Okay. And now they want, see how they write it right there? That's f double prime. That's another derivative. So they want d squared f dx squared. See the twos there? Means second derivative. I'll just put 2 prime. Same thing, whatever notation you prefer. That's Leibniz, that's Newton, whatever. We just got to take another derivative, right? So let's do it. So how do we take the derivative of minus 2x squared? Well, you know, power comes down, minus 2 times minus 2, plus 4x, subtract 1 from the power to the minus 3. That's the easy part. But now we got to take derivative of this. Well, how do we do it? Well, this is two functions of x multiplied. You might say, well, it's 3, it's 6. No, just include the 6 with the first part. Let's make it easier. So basically we have two functions of x multiplied. We have 6 cosecant multiplied by cotangent. So that's the product rule. They're going to need to take turns. So the first one goes first. Oops, it's not the color I want to have. Okay. Plus. Okay, the 6 just sits in the front. Anytime you have a number multiplied by a function of x, it just sits there like a spectator. Cosecant, what's the derivative of this cosecant right here? Well, cosecant, it says right here, cosecant is negative cosecant cotangent. It'll be negative, oops, cosecant x, cotangent x, times the other cotangent x, which is just sitting there. Now, it's the other one's turn, plus 6 cosecant x, this guy just sits there, times the derivative of the second guy. What's the derivative of cotan? Right here, derivative of cotan is negative cosecant squared of x. All right, that wasn't easy. Did you see that? Let me recap what just happened there. So to take the derivative of this part, I realized it's two functions of x multiplied. That means we got to do the product rule. So you got to do the first function, the 6 cosecant. How do you do that? 6, and the derivative of cosecant is minus cosecant cotangent. The second function, the cotangent, just sits there. And then the first function just sits there, 6 cosecant, and it's the second function's derivative term. Derivative of cotan is negative cosecant squared. So right there. Now, can we clean that up a little bit? Maybe a little bit. This will be 4x to the minus 3. Sorry, my 3's are a little crazy. Plus, there's a plus. Oh, this is going to be positive times negative. It's going to be negative 6 cosecant x cotangent squared of x. Sorry, I'm just getting scribbly here. Right? Because cotan times cotan makes cotan squared. It's positive 6 times negative, so it's negative. Plus, well, actually, positive 6 cosecant times negative is going to be negative 6 cosecant cubed of x, right? Because it's cosecant times cosecant squared, cosecant cubed. And there we go. That's the second derivative of it. And yeah, we got it right. Minus 6 cosecant cotangent squared. 4 over x. So, yep. There we go. That was quite a bit of work. So be careful with those derivatives. Know your product rules. There we go.